So we shall now move on to some other measures of variation, which is the coefficient of variation. It's very similar to what we've done so far because it involves mean and standard deviation. However, this becomes useful when you are comparing two data sets or more to know which of the data sets has more variation than the other. You cannot just look at their standard deviations and conclude that the one that has a higher standard deviation has more variability. No, because somebody may have a big standard deviation, but may also have a very big mean. And once the standard deviation and the mean are that huge, it can make his or her overall variation not be as huge as you may be thinking if you are comparing just the standard deviations. So coefficient of variation comes in handy when you are comparing two or more data sets. Please take notes. The formula is simply S standard deviation over the mean times 100%, okay? Once again, remember we are focusing on the sample, not populations. So there's an example here. The mean of the number of sales of cars over a 3-month period is 87, and the standard deviation is 5. Now the mean of commissions is 5225, and the standard deviation is 773, okay? Now compare the variations of the two. If you use the formula for coefficient of variation, for sales, we have 5 over 87 times 100%, which is 5.7%. Then for commissions, we have 773 over 5225 times 100%, which is 14.8%. So you can see that commissions are more variable than sales, looking at their standard and their coefficient of variation, all right? Now then another measure we want to look at is the coefficient of skewness. Now skewness is just telling us the distribution of our data sets, okay? And how much the data is distributed about the mean. So if, for example, if the average age of students in your class is 25, and in the class there are 30 students, okay? There are 30 students. The average age is 25 years old. But it happens that 20 of you are above 25 years old. Only 10 are below 25 years old. We say that the ages of students in your class is not, we call it, is not symmetrical. If the ages are symmetrical, then to mean that 15 students are above 25, 15 students are below 25, evenly distributed, okay? If I can say so, is the closest example I can give you, but it is not absolutely the case. There can be something, because even if there are 15 students above 25, and then those 15 students are, for example, 40 years, 50 years, and then those who are below 25 are more of 20 years, 21 years, your data is still not symmetrical, all right? So we are looking at a case where skewness is just checking how distributed your data set is around the mean. And this is the formula you use to find the skewness. So you will need to find the skewness of in data sets, you need a mean, you need a this is the median. MD is the median, yes, and then S is the standard deviation. So the example here, using the formula, find the coefficient of skewness for each distribution and describe the shape of the distribution. So you can give this a try. We can talk about this when we meet in class. Okay. Please make sure you do a little bit of reading, further reading on this. Don't come to class saying that, Madam, I couldn't do it. Try and read further, okay, for more insights before you come to class, and then we can discuss. Now let's look at some measures of position. These are the final measures when it comes to computing summary statistics. We've looked at some measures of central tendency. We've looked at some measures of variation. Finally, we want to look at some measures of position. Okay, so These measures include standard scores, percentiles, quartiles, and they are used to locate relative position of a data value in any data sets. Okay. So for example, if you wrote an exam and I told you that you scored the 80th percentile, it means that 80% of the values, or you did better than 80% of the students in the class. Okay. Only 20% of the students in the class did better than you did. So the first one is the standard score, the Z-score. It's used, this is the formula for it, okay? It represents the number of standard deviations that a data value falls above or below the mean. So it is a way of describing the position of a particular data point regarding its mean, okay? So that's just it. How do you find, if you know what value you are considering? If you're looking at a data set of, say, ages of students in your class, once we know the mean of the ages and the standard deviation of the ages, if I'm considering a particular data point, somebody who is, let's say, 30 years, I fixing the age of the person, might take away the mean of the ages in the class and divide it by the standard deviation, and that gives me the Z-score, all right? So for example here, it says a student scored 65 on a numeracy skills test that had a mean of 50 and a standard deviation of 10. She scored 30 on a communication skills test with a mean of 25 and a standard deviation of 5. Compare her relative positions on these two sets. So once you see you have these data points where there is a score, a mean, and a standard deviation, you can use the Z-score to compare the students' performance, okay? So here the Z-score for numeracy skills is 1.5, for com skills is 1.0. Okay. So comparatively, if you look at the variation around the mean, the students perform much better in communication skills because he's just one standard deviation around the mean. Now let's move on to the next measure of position, which is called percentiles. What are percentiles? Now, percentiles are position measures that are used in many areas such as educational level, health-related fields, and all of that to indicate position of an individual in a group, okay? So percentiles divide an entire data set into 100 equal parts. And these are the notations we use. P1 is the first percentile, P2, second percentile, P3, third percentile, all the way to P99, the 99th percentile. So the percentile corresponding to any given value X is computed by using the following formula. Your percentile rank is number of values below X plus 0.5 times the frequency of that particular X value divided by the total number of values times 100%. So let's take an example. A teacher gives a 20-point test to 10 students. The scores are shown here. Find the percentile rank of a score of 12. So the first thing is to arrange this data sets in order, which has been done over here, okay? Now, our focus is on this number. We want to know what is his or her percentile position. What is this number's percentile position amongst this entire data set? So knowing that the number is 12, the first thing is how many values are below 12? We have 1, 2, 3, 4, 5, 6. So 6 of them are below 12. So you put in 6 in this bracket. How many times has 12 occurred? Just once. So the F here becomes 1, okay? This is 0.5, not 0.05. Please take note and then I'll do the correction. Then total number of values, there are 10 students involved, so it's equal to 10. So the percentile is 6 plus 0.5 over 10 times 100, which is 65th percentile. So we say the percentile position of the number 12 among this data set is 65th percentile, which means that this person who scored 12 did better than 65% of the students in the class. Only 35% of the students did better than him or she. Now, you may also want to find the value of X corresponding to a given percentile. Okay, that's the opposite of what we've just done. Now we want to know if you have a data set, which of these values represents, for example, the 70th percentile. The formula you use is this, where K represents the particular position or the particular percentile you are talking about. So if you're talking about 70th percentile, then K here will be 70. If you are referring to 50th percentile, then K here will be 50. N is the total number of data sets we are considering. So now let's look at an example. It says, find the 70th percentile of the data sets given. Find the 70th percentile of the data sets given. We have these data sets 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 of them, but they are not orderly arranged. So the first step for you is to arrange them in order. All right. Now, knowing that there are 9 of them, it means n is equal to 9. We are trying to find the 70th percentile. So k is 70. So once you know your k and you know your n, it's all about fixing in these values in the formula. Eventually, you're getting 7. So the seventh, in finding the 70th percentile, you're looking for the 7th position of this data set. So you start counting. This is the first, the second, the third, the fourth, the fifth, the sixth, the seventh. So the number 30 is the 7th percentile, the 70th, sorry. The number 7 is the 70th percentile of this data set. Now the third measure of position we want to look at is quartiles. Quartiles. Now we mentioned earlier about percentiles, where percentiles divide a kind of some data sets into 100 equal parts. Quartiles divide a data set into just 4 different parts, okay? And we have these ones that set the data parts. Q1 separates the first group from the second group. Q2 separates second group from third. Q3 separates third group from fourth. So we call Q1. Q1 is also in percentile form. Q1 will be known as the 55th percentile. Q2 is the same as the 50th percentile or the median. And then Q3 is the 75th percentile. Okay. So to find the data values corresponding to, for example, first quartile. So if I give a data set and I ask you what's the second quartile or what's the third quartile, a very easy way you can actually use a percentile formula. By if you find Q1, you look for 25th percentile. To find Q2, you look for 50th percentile, and so on. But another easy way, more especially if your data set is not so huge, you have like maybe 15 data points or 20 data points, what you can do is just arrange the data in order from lowest to highest. Find the median of this data set. Once you find the median, you found the second quartile, which is Q2. Then find the median of the data values. That look for all the values below Q2. Consider them and find their median also. That median will give you Q1, which is your first quartile. Now consider all the values that are above Q2 or above the median, and then take just those values and find the median of just those values, which will give you Q3, the third quartile. Okay. So once you have these values, there's another concept we call interquartile range. The interquartile range is the difference between the first quartile and then the third quartile. So if you want to find Q1 and Q3, it's very simple to find the interquartile range. It's just Q3 minus Q1. Now let's take note of this important definition. We call this outlier. Now an outlier is an extremely high or an extremely low data value when compared with the rest of the data values. So for example, if I'm considering ages of students in your class, and most of you fall between the age 20 and 30, and there's just one person who is 50 years old, we call that person's age as an outlier because it's extremely high when compared to the rest of the data points. I hope it's clear. Now, finally, we want to look at the concept called a box plot. Now, a box plot is just a graphical representation of some data sets, like we did with histograms and frequency polygon. A box plot is also another way of graphically representing your data set to make more meaning. However, it makes use of the quartiles and median we have just learned. That's why we are seeing it here and not in our previous class. So to draw a box plot, you need your 5-number summary. We call something the 5-number summary. What constitutes the 5-number summary? The first one is, what is the smallest number in my data? Then what's the biggest number in my data? Then let me find my first quartile. Let me find my third quartile, and then let me find my median or my second quartile. So these 5 elements form your 5-number summary that you need to draw your box plots. So it's a graph of a data set obtained by drawing a horizontal line from the minimum data value to Q1. Then you draw a horizontal line from Q3 to the maximum value, okay? Yes. And then you draw a box whose vertical size pass through Q1 and Q3 with a vertical line inside the box passing through Q2. So here, the procedure for constructing the box plot is provided over here. I provided a graph of this is a data set, okay? And then I use this data set to follow the procedure. First of all, arrange data in order, find the median, find Q1, Q3, and then find the lowest and the highest values. And then I attempted to draw this box plot. This box plot came out not as you would expect because of the software I used. Ideally, these numbers will be better if these numbers are rather on the horizontal axis. So I would want you to replicate this, do this again using graph sheets, okay? Redo this particular exercise, and then let the labeling, instead of they being on the vertical axis, let them show on the horizontal axis so that your box plots will be turned. This line here will rather show somewhere here, and then your entire box plots will turn. So I would want you to replicate this particular exercise using this particular example, draw a box plot. But as I'm saying, take notes, let these values rather be on your horizontal axis. So your box is going to turn. Let's see what you come up with, the outputs you come up with, and we will talk about it in class. So before we go, I've given you 3 different projects. The first one is you're finding the median and the mode of some grouped frequency table, which is given in this as in the notes. It's provided in the notes. Okay. Then the second one is I want you to reproduce this box plots following the instructions for the procedure and then using this data and making sure that your horizontal axis radar is labeled with these numbers, okay, or whatever scale you choose to use. So this brings us to the end of this section. I encourage you to redo every exercise in here that we have considered. All these exercises that we did, the examples I solved with you, I went through with you within this particular online session. Sit down, get your exercise books, your pens and your calculators, get your graph sheets and reproduce these exercises because that is the only way for you to identify the areas that you don't fully understand and to deepen your understanding in the areas that you fully understand. If you're having issues, consult a friend for some help. If you are not able to get any help, make sure you take notes and then bring these things up in class. I expect that you practice every single exercise in here. When we meet in class, before I accept that you ask any question, I will inspect to see in your notes that you actually practice every single example in these notes. All the graph about the box plot I've asked you to draw, make sure you draw it. Every single exercise in here we have gone through, make sure you redo it to see if you really get what we have gone through. I wish you the very best in your studies, and we will meet in class next week. Thank you for joining this online session.